Okay, let's start this off as a bit of a review of what linear inequalities are. Suppose I want to buy coffees for my Math 95 students. Each coffee costs $2.50. I will give the barista a $3 tip. Okay, I need to spend less than $28. How many coffees can I buy? Okay, so each coffee is $2.50, so $2.50. I'm going to call X how many coffees I can buy. So everyone's going to cost $2.50. Plus, I'm going to have a $3 tip. And it needs to be less than 28 bucks. This is a linear inequality. And I could solve that. Minus 3, get 250x equals 25. Divide both sides by 2.5. And 25 divided by 2.5 is 10. I can only buy less than 10. Okay, so because that's not going to work because I need more than 10. But there we go. So there's how I would solve it. Okay, now let's look graphically at solving these. So here's a function. F of x equals x minus 1. It's a linear function. And I'm going to have that equal to 2, and then less than 2, and then greater than or equal to 2. And I want to solve each of these. So for the first one is an equation, and so we know we would just add 1, and we would get x equals 3. Okay, one solution. But the other two are inequalities, which means we have infinite solutions. So we're going to add 1 to both sides, same, but this is all the numbers that are less than 3 will be less than 2 in the equation. And this one, if I add 1, are going to be all the numbers greater than or equal to 3. Solve the inequality. Okay, so looking at the graph, we have x minus 1 graphed here. Okay, and then I want to know where, write these down here, x minus 1 is equal to 2, where x minus 1 is less than 2, and where x minus 1 is greater than or equal to 2. Okay, so where it's equal to 2, well, we see that that was at 3. Exactly, x equals to 3. 1, 2, 3. Sure enough, it's equal to 2. Here's my 2. Okay, so this is where it's equal to 2. I'm going to draw a line because now I want to know where that line or that function is less than 2. And that's going to be right here. Okay, but I don't want to talk about it there. I need to talk about it on the x coordinates. Okay, because we used, where it's equal to 2, we used the x coordinate of 3 right here. So where it's less than 2, we need to use all these x coordinates, okay, which is everything less than 3, or from negative infinity to 3, not including 3. That's where it's less than 2. And where it's greater than 2 is up here. We want to use all of these x coordinates, which would be from 3 to positive infinity, or where x is greater than, oh, this one was equal to, so we better do equal to 3. Whereas this one was x is less than 3. Okay, so we'll verify those right here. Here's our x is less than 3. Here's our x is greater than or equal to 3. Okay, so take a look at that. We're going to be solving inequalities where we have a function, which is the line, and we want to know where that function is, first of all, equal to 2, and then less than 2, that goes forever, and then greater than or equal to 2. All right, and we answer that with the x values. All right, let's look at another one. All right, now what happens when we get two inequalities into a single problem? We have a compound inequality. So now I want to buy X coffees. They're $2.50 each plus $3 a tip. I can spend between $15.50 and $28. So let's look at a compound inequality. So now I know I have $2.50 for each X plus $3 tip. So it needs to be less than 28 or greater than $15.50. Now that's what you call a compound inequality, okay? So I'm going to look at both cases. So what I'm going to do is I want to get the x by itself. So I'm going to minus 3 from all 3 pieces. This is called a 3-piece inequality. And I'll get 1250 is less than 250x is less than 25. Then I'm going to divide all 3 by 2.5. So let's see, 12.50 divided by 2.5 is 5. Oh, I could see it on my graph there. Is less than x is less than, and then we know we did this already, 25 divided by that is 10. So I can buy between 5 and 10 cups of coffee. Now on the right here is a graph of this. And so the purple line is still my 250 right here. Actually, we'll go right here is my 250x plus 3. And then I have my less than 1550 is my low, and then 28 is my high. And I want to know where it fits between those, and that is if I go down to the x-axis, that's going to be 5, and if I go down to the x-axis, that's 10. So in between, right here, in between 5 and 10 is where my function value will be between 15.5 and 28 on the y-axis. Okay. All right, here's another 3-part inequality. Let's solve 3-part inequality. Let's go ahead and solve this one. So I see fractions. I'm going to times everybody by a fraction. First of all, by the denominator of 3, okay? Because the common denominator is 3. So times u by 3, u by 3, and u by 3. Why? To cancel them out. All right, so the whole point is these will cancel, and I'll be left with a negative 4. These cancel, and I'm left with 2 minus x. And nothing cancels there, but I get a 3 times 5 is 15. Okay, now I need to get that x by itself. Ooh, it has a negative in front of it. That's going to do something, but let's minus 2 from everybody. And I'll get negative 6, and then I have a negative x, and then I have 13. The problem is the negative on the x, so I'm going to times everybody by negative 1, or divide. And what happens then is the signs flip, if you recall, working with inequalities. So I'm going to divide everybody by negative 1, which means I automatically make these flipped inequalities. This becomes a regular x, this becomes a positive 6, and this becomes a negative 13. Now, what I'm going to do next is really important. These signs are not pointing to the left. They're in opposite form of a number line. In other words, we want less on the left. So I'm going to rewrite the negative 13 is less than or equal to x is less than 6. Notice I flipped the signs. This says 6 is greater than x. This says x is less than 6. As long as it's still pointing to the x and it's still pointing to the negative 13, this is my preferred way to look. And the reason is now I can look at that on an actual x-axis. In this case, this x-axis right here is going to be my points. And there's my negative 13, and there's my 6 right here. Okay, and that's in between. The graph is in between right here, the negative 6 and the 13. Okay. Okay. I'm going to stop the video here. This is a good place to stop.